Welcome back. In this lecture, let's continue on our discussion on matrix. So, in last lecture, we saw how do we initialize filled matrix of scalar value, and now let's see some built-in functions TensorFlow provides us in order to create the filled matrix of ready-made elements. So now let's start with zero elements. So if you want any array of the size m cross n with all the elements initialized to 0, we can do it very easily. So let's say my zeros as an object of TensorFlow for the method zeros. Okay, and we just need to call the m cross n value. Say let's call as 3 by 3 for this time. Shift enter, and it's try to print say my zeros. It's going to say it's of the floating point type, and by default it gives us the floating point 0.0 like, and the zeroth element is 0 of the dimension 3 by 3. And now when we execute this dot run and say my zeros, enter, we are going to get floating point zeros 0 dot of the cross of the dimension 3 by 3 ready-made array. So it means we can create a filled matrix of m cross n where each element is filled with value 0 using this line of code. So similarly, we have a built-in function in TensorFlow to give us a filled matrix of ones. So let's call that as my ones is equal to tf dot ones is a method, and we can specify the dimension what we want. Say let's call it as say 5 by 5, m is 5 and n is 5, and we execute. Say if you type my ones, it's going to tell me the ones matrix which TF has given is the first one, which is of the shape 5 by 5, the m cross n value of the array, and each element is 1.0. It's a floating point by default. And now if you want to see the contents, we just run sys.run and then call my ones, set that, and then do a shift enter. So we see we have a m cross n array, a matrix of the dimension 5 by 5, and each element has been initialized by 1, and which is of the type floating. So this way we can create a matrix of the dimension m cross n where each element is filled with value 1 using this line of code. Now in order to create a filled matrix with random values, so in real life we may not always need zeros and ones. Of course we need, but not mostly the case. But the random value filled matrix is mostly used. Let's see how do we create that. So let's call it as a myrand object of tf dot random. There are various options in random. Let's begin with a normal random operation and give it as say dimension 4 cross 4, and we initialize the mean value to be 0, and we need to give the standard deviation value to be 1.0. So to create a filled matrix with each element initialized to a random value of say 4 rows and 4 columns, 4 cross 4 matrix, we need to run this line of code where the mean is initialized to 0 and standard deviation is initialized to 1. And when we execute this line of code, and I'm not going to type print anymore, it's assumed now, I think we know what it is. So let's call the sys.run method on my rand and execute. So we see we have an array of matrix of dimension 4 cross 4 initialized with some random floating point values. So it means we can create a filled matrix of m cross n where each element is filled with random values using the following line of code. Okay, and next let's see how do we initialize a matrix with random value where all the elements are uniform. Here we see all the elements are not uniform. Let's see how do we create a matrix where all the elements are not uniform. So we call, let's say we have any object like my rand u equal to tf dot rand. In this case we call uniform, and let's say we want some dimension, or let's choose a newer one, let's say 3.3 3 cross 3, and minimum value equal to 0 and max value equal to 1, and we execute this line, and then sys dot run will run my randu. Enter. Now we see that we have created a filled matrix of m cross n where each element is filled with a value random using the following code, and we get initialized matrix which is in the range 0 to 1, and it has been uniformly distributed. It's not a very although it is random, it is uniformly distributed. So these are some of the built-in matrix which TF has to offer, which we'll be using. So that's it for this session. So if you like this video, hit the like button and don't forget to subscribe. Thanks for watching. See you in the next lecture. Until then, bye bye.